So far, when we're graphing our trig functions, we've talked about the sine function and the cosine function. The last function we're going to talk about is the tangent function. When we look at the tangent function, we can see here's a graph of it, 3 different periods of it, complete periods of it here. It is not an oscillating function. It is a function that has 2 asymptotes. And our asymptotes are where the function cannot cross. You'll see the function will approach that asymptote on both sides, but it will actually approach infinity. It will never actually be equal to anything at these 2 locations in our x values. So that's the major difference. So what we need to do is we need to be able to find the distance or the period between these 2 asymptotes. We've got to be able to find this central location here, and we've got to understand how quickly or how slowly these tangent functions are actually approaching infinity. So if we look, the general form of our tangent function is going to be a tangent times bx minus c plus d. A is going to be, we have the same variables a, b, c, and d here. You can see our a value used to tell us what the amplitude is. At this point, it's not going to tell us our amplitude. It's just going to tell us whether it's stretched, whether it's compressed, or how quickly it's going to be approaching infinity. If it is a negative, it's going to tell us that there's a reflection in the graph. So instead of our tangent function looking like this, if it's negative, it's going to flip it and reflect it across that x-axis. The period is another change. So to find the period, now before we were using 2 pi divided by b for cosine and sine. Now we're just going to use pi over b. So we're going to take pi over b and we're going to find what it is. So in our generic equation of tangent, when we just have tangent of x, our period is pi, which means it exists for pi at a time. Vertical translation and our phase shift do not change. Vertical transformation tells us if we're moving it up or down in the y direction and how much we are, and our phase shift tells us where that x point is going to be located, left or right. And for our trig function, our x point is always going to be our 0. We just have to find where that is, in fact, located. So if we look, we've got an example. Tangent of x plus pi. Our amplitude, we can see our a value here is just going to be a 1. So my a value here is just a 1, which means it's not negative, it's not reflected, and it's traveling like a typical tangent function would. Now remember, it's going to go to negative infinity and infinity. My period then is going to be pi over b. My b value is whatever I have next to my x. My b value is a 1. So my period is going to be pi over 1, or just pi. My phase shift then, we said our phase shift is c over b. My c value is pi. My b value is 1, so my phase shift is going to be pi over 1, or just pi. And I do not have a vertical shift here. Next thing I got to do, I've got to label my axis. My axes should be pretty consistent. I like to go by pi over 2 unless there's a glaring need to do something else. So I've got 3 pi over 2, 2 pi, that should be enough, and these are all going to be negatives. Going the other way, I'll have pi over 2, pi, 3 pi over 2, and 2 pi. Alright, so my phase shift tells me where it is that my trig function crosses the x-axis. Since there is no vertical shift, it's going to be the x-axis. A plus sign here changes things up for you, so it's going to be a shift to the left. So I'm going to shift it to the left here. So I've got my phase shift where I shift it pi to the left. From there I want to get my period. My period was pi, which means that on the right side and on the left side I should have an asymptote of pi over 2. Which means my entire function here should should have a period of pi, which it does now. So from here I will just make an asymptote every pi or every 180 degrees, and I can draw my function. Since it's not reflected, it'll just be a typical tangent function crossing over the x-axis in the middle. And I've got one more example for us here. This one should have a little bit of everything. Good, so this one's got our amplitude is 2, but again, remember it's going to infinity. It's not 8, it's going to infinity and negative infinity, so we don't have to worry about it. Our period is going to be pi over b. My b is a 2, so my period is pi over 2. My phase shift will be c over b, so it's going to be pi over 2. Since it is a minus, it'll be to the right. Remember, we're talking opposite. So we'll be talking to the right, and I've got a phase shift here of positive 2. So everything's going to be shifted up on this line of positive 2. And same thing, I'll label my axes same way I did before. Remember, we did a couple in class where we did pi over 3. It all depends on the problem and how you want it to be arranged. So my shift, I was up 2 units, so I moved up here, and it was to the right, pi over 2, so I will start it right here. My period is pi over 2, which means to the right I will have pi over 4 or 45 degrees. To the left I'll have 45 degrees. And then I can make every pi over 2 will have an asymptote as well. And last thing left is this is a positive, no reflection. I can fill in my tangent lines. Again, once we have our asymptotes, really we just draw in our tangents, and that gives us a rough idea of what this function is going to look like.